Hi everyone, welcome back to Epidemiology Research Methods. This is Module 5, the last module, and we will talk about cross-sectional and ecological studies. Cross-sectional studies are a snapshot of disease prevalence at a point in time. This means that all of the necessary information, exposure, and outcome is obtained from subjects in one snapshot rather than over a period of time. So, all the information needed to conduct the study is gathered at one set point. For example, a random study of students asks two questions. The first question is, are you taking more than 16 units? The second question is, how stressed do you feel on a scale of 1 to 10? In this case, the exposure would be taking more than 16 units and the outcome would be stress level. For this kind of study, it is very common to do a survey like this because a survey is a good way to obtain snapshot information. So, since the investigator only has a point in time to study, only prevalence can be measured instead of incident cases because the likelihood of an incident case occurring right in that one moment that the investigator is studying is very unlikely. So it's really only prevalent cases that will show up in this data. So going back to our example, students taking more than 16 units with a stress level of greater than 5 are in Group A. Students taking more than 16 units with a stress level of less than 5 are Group B. Students taking less than 16 units with a stress level of greater than 5 is Group C. Students taking less than 16 units with a stress level of less than 5 is Group D. So the prevalence of high stress in the exposed students would be students taking many units with a high stress level divided by the total population of students taking many units. And the prevalence of high stress in unexposed students would be students taking few units with a high stress level divided by the entire population of students taking few units. Some advantages of cross-sectional studies include that they require relatively few resources to conduct. It doesn't take a whole lot of time to gather and analyze the data. And these studies provide information at the population level, which can be useful in, for example, community health. A disadvantage, however, is that information is limited given the lack of follow-up. There is not a whole lot of information that can be gleaned from such a short follow-up period. Ecological studies observe populations rather than individuals. Ecological studies compare the measurement of an exposure in populations to the measurement of an outcome in populations. Ecological studies are often portrayed in a scatter plot like this. So this particular study compares the incidence rate per 100,000 of ovarian cancer in 2014 versus smokers in 2014. So this scatter plot is an interesting one because it actually shows a negative association between smoking and ovarian cancer. So it would appear that there is a protective effect on ovarian cancer for smokers. However, I put together this scatter plot myself from some data in a database and I made a mistake. I included men in the smoking data. However, obviously men would not be included in the ovarian cancer data. So That just is a good example of how important it is to make sure that you are collecting your data correctly and analyzing it correctly, because there are major impacts on your outcomes if your data is not collected correctly. So let's do an example. Our populations are women in Northern California, women in Montana, and women in the Northeast. The exposure is hours per week of exercise done by women in the population. The outcome is the average lifespan of women in the population. If women in Northern California on average exercise more hours per week than in Montana and the Northeast, and if women in Northern California on average have a longer lifespan, hours per week of exercise may be correlated to longer lifespans. Ecological studies, however, are subject to the ecological fallacy. Since ecological studies look at populations rather than individuals, it is possible that the individuals experiencing an outcome are not necessarily the individuals who were exposed. For example, the women in Northern California exercising many hours per week are not necessarily the women who are living longer. Going back to my ovarian cancer versus smoking example, those who were smoking were not necessarily those who were getting or at risk for ovarian cancer. This can lead to false associations, and it is called the ecological fallacy. So, what kind of study is susceptible to recall bias? That would be a retrospective cohort study. And if you can remember, the reason for that is because in a retrospective cohort study, we're often counting on subjects to provide information from memory, and their memories can be incomplete or incorrect. Next, what kind of study is considered the gold standard of research study designs? Randomized control trials are the gold standard of research study designs because they provide the most accurate comparison of a treatment group and a control group. Next, an odds ratio is an estimation of what? An odds ratio is an estimation of relative risk. They are not calculated the same, but they are interpreted somewhat similarly. True or false? Epidemiologists seek to prove causation between exposures and outcomes. This is false. Epidemiologists seek to find correlations between exposures and outcomes. Since we are nearing the end of our 5 modules, I thought we could circle back to our friend Dr. John Snow while we go over some of the study questions that I included in the training document that goes along with this 5-module project. The question that I wanted to go over is, what kind of study design did John Snow use when determining the source of the cholera outbreak in London, 1854? I wanted to go over this particular question because I wanted less to show what kind of study this was and more to show what kind of study it isn't. So I think that it might be easy to think that maybe this was a randomized control trial because the houses in the neighborhood with water from the Broad Street pump, those were the exposed, and the houses who received their water from the other pump, those were the unexposed, and this was kind of random. I want to point out, though, that this is not a randomized control trial because there was no action on a part of the investigator, who is Dr. John Snow. This is actually a case control study because it is an observational study. Lastly, I wanted to talk about the question, why is it important to study disease patterns? It's important to study diseases because when we understand disease patterns, we can learn how to prevent them in the future, which is the whole point of public health, and it's why I think epidemiology is so great. Thank you so much for joining me through these 5 modules of epidemiology research methods. So just to recap, we have gone over cohort studies, we have gone over case control studies, randomized control trials, cross-sectional studies, and ecological studies. These are not the only types of epidemiology study designs that exist. They are simply the main ones. I hope now that you can feel confident looking in any epidemiology journal and really understanding what you're reading when you read these studies. And I hope you've enjoyed the time that you have spent with me over the past few modules. And I want to remind you one more time to take a look at the training document that goes along with this course. It does contain some great study questions as well as reading recommendations and such. Thank you again, and I will speak with you next time.